Welcome to homework.
So our target of synthesis is benzylamine. So how can we get there? Starting from benzyl bromide. That's quite simple if we remember our Gabriel synthesis. So first we can toss in potassium phthalimide. And then hydrolyze this amide with 2 equivalents sodium hydroxide and we can access our benzylamine. If we're starting from the nitrile, we can reduce this down with hydrogen gas in the presence of palladium on carbon to get to our benzylamine. If we have a primary amide, we can use lithium aluminum hydride Of course, we would need to rebasify to get to our free base amine. If we're starting with benzaldehyde, we can simply go through a reductive amination with ammonia and a less nucleophilic reducing agent. And this will directly access the benzylamine. If we just have toluene, we can first use NBS in light to selectively brominate at this position. And then we can do the same step as our first reaction, since that was also benzyl bromide, to access the benzyl amine. If we have the carboxylic acid, we can first get to the ester, say with thionyl chloride and methanol. Next, we can use ammonia with a lot of heat to drive this reaction to the primary amide. At that point, it is the same as C. So we would again use lithium aluminum hydride followed by acidic and basic workups to get to the benzyl amine. Next, we have aniline. So if we use NaNO2 and nitric acid, we can access this salt as a very good leaving group. Next, we'd want to use, say, some alkylating source. Or alternate route is to use copper bromide to get to the aryl bromide, then use zinc and CO2 gas in your Reformatsky reaction conditions to get to the carboxylic acid, at which point you can follow the exact same as F to get to your final product. And last but not least, if we're just starting with benzene, we can go through bromination. And at this point, you can follow the same reaction scheme as above in G to access the benzylamine.